Today we're going to be talking about the coordinates on the unit circle. So later, once we kind of like delve into things a little bit and get a better understanding, hopefully, we're going to go back to those beautiful circles that we drew freehand, all right, and we're going to add in some coordinates, all right. This thing, right, it's called the unit circle. The reason why it's called the unit circle is because we imagine the circle to be a radius of 1 and it's centered at the origin. So that's the unit idea, right? It's a radius of 1 and it's centered at the origin. And so then as a result, this is being in the coordinate plane, the location of this point on this unit circle, right, location of this point should have an x and a y coordinate. Likewise, 45 degrees, you know, this 45-degree angle, but on the unit circle, this point, this should have a coordinate, and likewise for all these other angles. Okay? Yeah, and so we're going to identify those coordinates today, what those x and y coordinates are. And we're going to start first by focusing just on that first quadrant. The first quadrant is really nice, right? It's got positive x values, positive y values, and so we'll then kind of get the rest once we figure out those coordinates. Okay? So, let me kind of draw a maybe a blown up version here of that unit circle in the first quadrant. So let's see here. I'll draw. There's my y-axis. There's my x-axis. Oops. I'm going to go like that. And then I will kind of draw a quarter of a circle as best I can there. Yeah, it's pretty good. Okay, now, some of these coordinates on the unit circle are going to be super easy for us. All right, for example, right here, right, that point right there on the unit circle, I know it keeps going, I can put some like dotted lines there to show that it keeps going. All right there on the unit circle at 0 degrees or 0 radians, okay, what would the coordinate of that point have to be? Remember, our circle is the unit circle, so it has a radius of 1. So what would the coordinates have to be there? Yeah, Deb?
1, 0.
Yeah, 1, 0, right? 1, 0. 1, 0. Okay, 1, 0. X coordinate is 1 out, right? Y coordinate is not up or down at all, so it's just the y coordinate 0. So 1, 0. Easy peasy. Likewise up here, okay, at the 90-degree or pi over 2 radian measure, okay, another easy one, right? What would the coordinates for this point be on our unit circle? 0, 1. Right, yeah, 0, 1. Okay. Again, now we're not left or right at all. We're just straight up on the y-axis. We're 1 unit away. Again, how do we know it's 1? Well, because again, this is the unit circle. Radius is 1. Radius is 1. All right. So that takes care of those easy ones. But then the next angle that we come across after 0 degrees on our way around, okay, to the pi over 2 or 90 degrees, all right, is the 30-degree angle. I'm going to put that over here. 30 degrees, or again, pi over 6. And so the question is, right, what's the coordinate of those? What's the coordinate of that point? We can say some things, right? For example, the x-coordinate here, x-coordinate for 30 degrees, it's going to have to be less than 1. Right? If this is 1, we're a little bit in from that 1, so it's got to be less than 1. Likewise, you can say the y-coordinate's got to be greater than 0, right? Because we're higher up than 0 on the y-axis there. So it's got to be, x-coordinate's got to be less than 1, y-coordinate's got to be greater than 0, so I have to do maybe this kind of eyeballing here. But what can we do? Well, remember this 30-degree angle, it's a 30-degree angle centered at the origin. So that 30 degrees, right, you can think of as really being measured right there. That 30 degrees, it's off the x-axis. Okay, we measure it off that x-axis there when we're talking about measuring angles there in the coordinate plane. The vertex of the angle, the pointy part of the angle is at the origin. Okay, and so then we want to find the x and y coordinate. Well, remember the x coordinate is some horizontal distance from the origin here. So this right here, right, is going to be the x, some x value. And likewise, this right here is going to be our y chord there. Horizontal and then a vertical, right? And so, of course, with that horizontal measurement and with this vertical measurement, what kind of shape have we now created there? What shape is that? A right triangle, right? And not only is it a right triangle, it is a 30, 60, 90 right triangle. So if we take this 30, 60, 90 right triangle out, okay, 30, 90, and that means this angle right here is going to be 60, right? Understood to be 60. Let's kind of like take this out here. Might be a whole lot of arrows. Bless you. Okay. And again, we want to find this x value and this y value. Right? Now notice here the hypotenuse. What do we know the hypotenuse of this triangle has to be? What value is that hypotenuse? What does it have to be? Yeah, Nick? 1. 1. Yeah, why?
Because every point on the circle is equidistant from the center.
Yeah, from the center here, right? This is, again, the unit circle. This hypotenuse of this right triangle, well, its hypotenuse has got to be 1 because it's also a radius of that unit circle. Unit circle, radius 1. So we know that's got to be 1. Okay. And so we go back to those 30, 60, 90 right triangle relationships, and there it is right there. Okay. There's your 30, 60, 90 right triangle relationships. So the 1, that's going to correspond to the 2A side. Okay. 1 kind of corresponds to that 2A side. So if you like put this in here. Y is going to correspond to the A side, and then x is going to correspond to the A times the square root of 3. Okay. Again, you can just see that from what's opposite what here. In the picture, right, 30 degrees, that's opposite the A. So in this case, the y, which is opposite 30 degrees, that's like our A. The 2A, which is the hypotenuse, that corresponds to the 1, so they're the same. And then the x is opposite the 60 degrees, so it's the A root 3. So if 2A then is 1, that means A is going to be what? If 2 times A is 1, what does A have to be? A little equation, what would it be? 1/2, right? It's got to be 1/2, right? If 2 times A is 1, then divide both sides by 2 here, you get A is 1/2. So that means this thing is just equal to 1/2. Okay. And if x is A times the square root of 3, well, again, we know what A is. A is 1/2. We just figured that out there. So it's going to be equal to 1/2 times the square root of 3, or putting it all together, the square root of 3 over 2. So it's just using our special right triangle relationships. Using our special right triangle relationships. All right, and so that yields then, for the x coordinate of this point, it's going to be the square root of 3 over 2 for the x coordinate, and then 1/2 for the y coordinate. Right, to match, to correspond to those legs right there. Okay. So we got that coordinate there, we got that coordinate there, we got that coordinate there. All right. So questions on any of that? Any questions where that comes from? Yeah, question.
Is the hypotenuse always going to be like 1 if we're doing it on the circle?
The hypotenuse, yes, should always be 1. Yeah, for all the rest of these relationships, we'll see. Yep. And there's no reason for that, I think, other than it just makes the calculations easier because you're working with number 1. Okay. But you can imagine just by the idea of similar triangles, you could just then, if for whatever reason, if the radius were 2 or 3 or 4, you just multiply all those coordinates by 2, 3, or 4 as well, by similarity and stuff like that. Okay. All right, let's try the other one. Any other questions, I should say, before we move on here? Any other questions? So that's the origin of those points. All right, so now I'm going to try another one here, and this one is going to get busier. So I'm going to try and maybe I'll draw another one down here, rather than trying to fit it all in one picture. Okay, that's better maybe. All right, so Again, we have the other angles. The next angle we're going to talk about, right, is 45 degree. That's what comes up next kind of in order here, or pi over 4. Put instead of a comma, put or pi over 4. Okay, so we'll draw, again, we want to find the x and y coordinate for this point on the unit circle. Okay, so what are the coordinates there? What x, what y? Well, again, if I drop, so that's a 45 degree angle there. Here is our x, and there is our y. What horizontal distance, what vertical distance? And so then again, I'm going to pull this triangle out. Ooh. And redraw it here. So it's a 45 degree, and so if that's 45, then the other angle has to be 45 degrees as well, right, by the, sum of the interior angles of the triangle. That's 180. Again, our hypotenuse is going to be what? 1. It's got to be 1. And we want to find these other two sides, x. Sorry, that's y. Y, right, and x. There we go. And so then, if it's a 45, 45, 90 triangle, it's got to follow these relationships here. It's got to follow these relationships. A, and then A times the square root of 2 is your hypotenuse. Okay, so that 1, right, that 1's going to correspond to the A square root of 2 side. Okay, so 1 is equal to A times the square root of 2. And then this is equal to A, and this is equal to A. X and Y both can be the same. Again, so hypotenuse triangle. So we solve, right? To solve this one, we're going to take A times root 2 equals 1. A root 2 equals 1, so it means A equals 1 over the square root of 2. Or if we rationalize that, root 2 over 2. Okay? And so then A is the square root of 2 over 2, and A is the square root of 2 over 2. Or X and Y are both root 2 over 2 and root 2 over 2. Okay, and so there's our coordinate. Questions on that one? Questions on that one? Okay, and don't worry, it won't take this long for every other quadrant here. Once you kind of get the first quadrant established, the other ones will fall into place pretty much, okay, from there. All right, the other ones will kind of fall into place. But there's our, we have one more angle here in this first quadrant we've got to deal with, right? We must deal with it. So, one more quarter view of the unit circle. So the last angle we're going to deal with here is this 60-degree angle, or pi over 3. Okay. Very good. 60 degrees is 1/3 of 180. Pi is equivalent to 180, so 1/3 of pi. Pi over 3 is the radian measure. Okay. So again, that 60 degrees, that comes from an angle from the unit circle there, or from the origin, vertex at the origin there. So there's the 60 degrees. Right? And again, we can drop down to find that x and y coordinate. And so we have the x here, the y here. And so it's another 30, 60, 90 right triangle, just oriented slightly differently from our first one. Okay. Radius or the hypotenuse is 1. Okay, and again, we want to find x, we want to find y. Okay, so you can go right back to that 30-60-90 relationship here. Just again, we have to kind of change your orientation a little bit. The 1 is still the hypotenuse there. So the 1 is still equal to 2a. Okay. The 30 degrees is, again, the x now is opposite that 30-degree side. So x is equal to then just a. And then it's the y that's equal to the a times the square root of 3. But the same kind of math we did before, right? If 2 times a is 1, means a has to be 1/2. And so this little x coordinate here is going to be just the value of 1/2. And then it'll be 1/2 times the root 3, which is, again, just root 3 over 2. Okay? So 1/2, and then the square root of 3 over 2. And so then now, in summary, for that first quadrant, all right, we've got the coordinates here, 1, 0 at 0 degrees or 0 radians, okay, and then at 30 degrees or pi over 6, we have the coordinates root 3 over 2 comma 1/2, and then at 45 degrees or pi over what? 4. We've got root 2 over 2, root 2 over 2. And then at 60 degrees, or pi over 3, we've got 1/2 comma root 3 over 2. And then finally, at the 90 degrees, or pi over 2, we have the coordinates 0, 1. Okay? And so that's our entire first quadrant. So any questions on any of that? All right. So we come up with those coordinates there, and we wonder, okay, so why, right? Kind of, who cares, right? Why is this helpful? Well, the idea is, how does this relate back to our trigonometry? I mean, we kind of have used some trigonometry here, but how is this helpful? Well, if we go back to some of our earlier kind of angles and stuff like that here. For example, if I wanted to find, bless you, the sine, okay, of 30 degrees, all right, sine of 30 degrees, right? Sine is equal to opposite, so opposite is the y-coordinate, right, over the hypotenuse. Hypotenuse of this right triangle is going to be 1. So sine of 30 is just the y-coordinate over 1, y over 1. So sine of 30 degrees is the y-coordinate here. It's 1/2. Okay, right? Cosine of 30 degrees, cosine is the adjacent leg. So the adjacent leg here is this x-coordinate, right? Adjacent x over the hypotenuse, 1. So cosine of 30 degrees is x over 1. Cosine of 30 degrees then is just root 3 over 2. Okay? So sine of 30 degrees ends up being the y-coordinate. Cosine of 30 degrees ends up being the x-coordinate at that point. Okay? So that is cosine of 30 degrees, and that is sine of 30 degrees. Okay? They match up. All right? Let's go to the next triangle. 45, 45, 90. All right? Again, let's say cosine of 45 degrees. Cosine, again, is adjacent leg, the x-coordinate over the hypotenuse of 1. So cosine of 45 degrees is merely just the x-coordinate, root 2 over 2. So again, that is cosine of 45 degrees. It's the x-coordinate. Likewise, the y-coordinate. Sine. Sine of 45 is opposite y over hypotenuse 1. So the sine is, again, just the y-coordinate. Okay? And let's go once more here. Cosine. Cosine of 60 degrees, okay, is going to be the adjacent leg x over the hypotenuse 1. So cosine of 60 degrees is going to be 1/2. And then likewise, sine of 60 degrees by a similar argument is the y coordinate. So those coordinates are useful because they give us both the cosine for the x-coordinate or the sine for the y-coordinate at those particular values. This is true even for at 0 degrees. Okay? Cosine of 0 is 1. Cosine of 0 is 1. Sine of 0 is 0. All right? Likewise here, 90 degrees. Cosine of 90 degrees is 0. Sine of 90 degrees is 1. Those coordinates there, okay, can help you then identify sine and cosine without needing to use a calculator. All right? So through using the special right triangles, all right, and somewhat of our unit circle there too, we can identify precise values of sine and cosine without requiring a calculator. Okay? And so that's the purpose of learning this, is because we can, and so we will. All right. You could still just use a calculator though too, I guess, if that were available. Okay, so here's that. All right, so questions on that first quadrant. All right. So then let's take a look at quadrant 2, and I think we're only going to go up to quadrant 2 today. Okay, just to kind of see that. But once you get an idea about quadrant, really if you have quadrant 1 down, you'll be good for everything else. Excuse me. Okay. So quadrant 2 okay, and we'll say quadrant 1 here. We'll put both together. Alright, I'm going to try and draw this roughly. So I'm going to draw my x-axis kind of like down the center here, and I'm going to put a semicircle through here. So let's see if I can make this look halfway decent. Not bad. Okay, not too shabby, not too shabby. So again, unit circle, 0 degrees or 0 radians. It's got the coordinates of 1, 0. Here again, 30 degrees or pi over 6. It's got the coordinates of root 3 over 2, comma 1/2. Excuse me, here at 45 degrees or pi over 4. It's got root 2 over 2, root 2 over 2. And then here at 60 degrees or pi over 3, it's got 1/2 root 3 over 2. And then finally, again, finishing our quadrant, 90 degrees or pi over 2, we have the coordinates 0, 1. Whew. Okay, so there's that first quadrant. Second quadrant, all right, we got other angles here. For example, the second quadrant goes all the way around to 180 degrees, right, or pi radians. And then we have these second quadrant angles. Okay, so for example, back 30 degrees from the 180, if we go back 30 degrees, just like we went up 30 degrees from 0 degrees, right? If we go this way 30 degrees, we get to the next one, it's 150 degrees. So we go back 30 from 180, or going back pi over 6 from pi. So if we take pi over 6 away from pi, we're now going to be at 5 pi over 6, right? Pi is the same thing as 6 pi over 6. Taking away of pi over 6, we're at 5 pi over 6. Okay, same idea here. We're going to go back 45 degrees. Okay, so that's going to be 135 degrees. Okay, or going back to pi over 4, 3 pi over 4. Right? And then lastly, we have we're going to go back 60 degrees, so that's 120 degrees, or it'll be 2 pi over 3. So again, these angles over here in the second quadrant, they're not arbitrary. They match exactly, okay, or they correspond kind of to those angles that we have in the first quadrant, right? We think we're, in each case here, we're going back 30 degrees or forward 30 degrees. We're going back 45 or forward 45. We're going back 60 or forward 60 to get those other angles. Okay. So what do you notice about these points as compared to these points? And maybe it's my drawing that doesn't do a very good job here. How will the y-coordinates compare for each kind of pairing of points here? What's that?
Y-coordinates will be the same.
Same y-coordinates, and what's going to be true with the x-coordinates? Yeah?
They're basically negative versions.
Yeah, the negative versions. This is exactly a reflection over the y-axis. Okay? And by similar arguments, we could get these coordinates using the right triangles and stuff like that too. Because while, yes, this is 120 degrees this direction, and you can't make a right triangle with 120 degrees, we can come from the other direction here on the x-axis, and it'll be a 60-degree angle, again creating that 30, 60, 90 right triangle. Okay? And so the coordinates here will just be negative 1/2, positive root 3 over 2 for the 120 degrees. Okay? And then for the 135, it'll be negative root 2 over 2, positive root over 2. And then for the 150 degrees, it'll just be negative root 3 over 2, and then positive 1/2. Okay? And the 180 degrees or pi, I mean, that one we can even come up with without even using the reflection idea. We're going 1 in the negative direction here, and so it would just be the coordinates negative 1, 0, like that. Okay? The sine, cosine, and sine and cosine relationships still hold here, by the way. So in other words, if you were to type in your calculator sine of 120 degrees, you would get this y-coordinate, root 3 over 2. If you were to do cosine of 120 degrees or cosine of 2 pi over 3, you would get negative 1/2. Okay? Likewise with the 135. If you did sine of 135, that would be root 2 over 2, the y-coordinate, positive. If you did cosine of 135, it would be negative root 2 over 2, the x-coordinate. Okay? Negative. Right? One way I remember that cosine is the x-coordinate, sine is the y-coordinate, okay, of those points. And cosine comes first alphabetically, right? A, B, C, and then D, and then S for sine comes after that, right? And x comes first alphabetically, y comes second alphabetically. So x is first alphabetically, and cosine is first alphabetically. Sine is second alphabetically, and y coordinate second alphabetically too, just to help you remember that if you need help. So there's our first quadrant. There it is, and that's how we can evaluate all those different angles there, sine, cosine of any of those angles. Any questions on any of that? Okay, so that's all we're going to do today, all right? The time, remember again, the timed trig quiz tomorrow doesn't really, I mean, it does kind of involve this with the degrees and radians measures there. But of course, it's for the entire unit circle, not just the first two quadrants. Okay? So again, tomorrow's time trig quiz, the, converting from degrees to radians for 6 problems, and then converting from radians to degrees for 6 problems, total of 12, for all the angles on the unit circle there. So there won't be some weird, angles that you see. And then the following time trig quiz, so not tomorrow's, but the one after that, okay, it will be, I think, a 3-minute time trig quiz on sine and cosine for any angle in the first 2 quadrants, okay? So the next time trig quiz will be this, and you'll have to be giving me sine or cosine for any angle in the first 2 quadrants, okay? I'm not going to ask you for all of them, obviously. I will ask you for, random ones, all right? That'll be our next level. All right? But we're not there just yet. Okay? So, yeah. Okay? I've got for you here, I believe I'm supposed to give you this. Yeah, so let me get you guys started on your assignment here. Okay? That's that.